Welcome to qnawire.
This is problem number 70 of chapter 23. So this problem is based on the reading passage where they talk about 20/20 vision. So let's just do a review of what's given in the passage. They say that 20/20 vision, so 20/20, let's go ahead and use this type of text box. 20/20 vision allows a person to see letters that are 8.8 millimeters high from a distance of 20 feet. Okay, so this is one example that's given. And let's go ahead and see what this means for 20/40 vision. So here we are. 20/40 vision means that if someone has 20/40 vision, that means that a person with 20/20 vision can see at 40 feet what someone with 20/40 vision can see at 20 feet. Another way of saying that is that if a person with 20/40 vision is at 20 feet from the letters, they would have to be twice as high. So they would have to be twice as high as a person with 20/20 vision would need them to be able to see them. So a person with 20/20 vision, let's go ahead and draw a picture. If the letters are 20 feet away, here they are. This is the letter A. A person can resolve this, let's say, at a distance of 20 feet, provided they have 20/20 vision. So a person with 20/20 vision can see this, no problem, provided they are at least 8.8 millimeters high. So this is 20/20 vision. At this same distance of 20 feet, a person with 20/40 vision would need the letters to be twice as high because the ratio is 4:2 here, or you could say 2:4, but here 20/40, the way I like to think about it is 40 divided by 20 is 2. So the letters have to be twice as high here. So for a person of 20/40 vision, for them to be able to resolve the letters here, the letters would have to be 2 times 8.8 millimeters high for them to be able to be resolved. So let's see what that comes out to be. That's 17.6 millimeters. Okay, now the question asks, how high do the letters need to be for someone with 20/80 vision? So let's go ahead and continue the pattern. 20/80 vision. So notice the ratio. 80 divided by 20 is 4. So the letters would have to be 4 times as high. So here would be 4 times 8.8 millimeters. And we would get 35.2 millimeters, which the closest answer there, this is approximately the same as the answer given by option E, which is 34 millimeters. So letters would have to be 34 millimeters high at 20 feet so that a person with 20/80 vision should be able to resolve them. Okay, so the trick here, let's say if we were given another ratio, let's say 20/100, right? We would take this ratio 100, we would divide that by 20, so it would be 5 times. So we would multiply 8.8 millimeters 5 times to get the size of the letter so that a person with 20/100 can resolve those letters. So that's the pattern. Okay, final answer here would be E, 34 millimeters. This concludes problem number 7.